Hello, I'm Mason Steele.
And my name is Kieran Vacek.
Today we'll be presenting with the Prosthetics Compatibility Device team within the HSTEM enterprise. Oh, who are we? We are a sub-team within the HSTEM enterprise that focuses on the development of prosthetic compatibility device concepts. We're very multidisciplinary with majors such as biomedical engineering, mechanical engineering, electrical, and more.
A little bit of background about our project. Annually, 150,000 people undergo below-the-knee amputations every year. The customized prosthetics that these individuals use pose some challenges, such as very time-intensive construction to actually receive the prosthetic, a high cost towards the end user, and discomfort in areas that are in contact with the prosthetic. So our problem statement is to develop and test a device concept to reduce pain and friction worsened by the fitting process in below-the-knee amputees. Some requirements for our project is that we want an informative output for the end user, we want it to be adaptable for future improvements, and we want some long-term usability out of the device. So our device concept is a two-layer fabric sleeve that houses some circuitry within the two fabric layers. These circuitry measure pressure, intensity, and device deformation of our prosthetic device. And it is housed between the stump and the prosthetic and conducts measurements from there.
So in order to complete this project, we divided it down into three major areas of focus. The first area of focus is sensor research and development. The goal of this area is to determine ideal sensors and facilitate sensor integration. The second area of focus was software and electronics development. The goal of this area was to display and interpret pressure and strain data from the device utilizing custom circuitry and custom software. And the last area of focus was the prototype development area. And the goal here is to develop methods of construction and testing protocols, as well as pull together a lot of the concepts and work from the other areas of focus.
For sensors and gauges, what we discovered last semester is that the rubber cord sensors that we had been experimenting with were not as effective as previously thought. Based on the graph on the right here, after 3 trials conducted over 3 weeks, our R-squared values of our fitted data of the measurements went down significantly. This is due to plastic deformation in those sensors, which means that their sensor profile is not the same every time we run a test, which means they're not going to be super effective at taking data. So what we did is we made 2 decisions. We decided to switch from measuring pressure to FlexiForce sensors to measure pressure in specific areas. And to measure position and displacement, we switched to a variety of slide potentiometers.
So diving into the work on the custom software and custom electronics of this semester, we continued work on our custom software, which is coded in C++ with OpenGL. We designed a main controller board. We designed and manufactured our sensor driver boards as shown on the image on the right here. And we designed a programming board as to unload some of the programming circuitry from our sensor driver boards in order to enable miniaturization. And lastly, the goals of both of these components is to display data on a 3D rendering in our custom software.
So for prototype development, we researched methods to attach these stretch sensors to our device. So we came up with a fabric capacitance-based sensor that is able to be sewn into a sleeve. That would work really well for our device. We looked at some sensor matrix topology, figuring out how we wanted to arrange our sensors to collect data. And then attaching the pressure sensors to our device, we are looking into using silicone rubber to achieve this.
So where are we going from here? By the end of May 2025, we hope to have tested and proved a device concept in a lab environment. By the end of December 2025, we hope to test the device's applicability to clinical use and identify standards to move forward. And lastly, at the earliest, by the end of May 2026, we hope to begin optimizing the concept for an end product.
Thank you for watching our Design Expo presentation for 2024.